Hey guys, how's it going? Welcome to week one's advanced concept presentation. Today I'm going to be demonstrating the process of osmosis, osmotic uh, pressure using some Haribo gummy bears and 2 cups with different solutions. And we have one solution filled with just distilled water, water purified, and second solution is uh, saturated, water saturated with salt. And so I already filled these 2 cups up. One was with just the distilled water I have lying around in my house. And second one, I just poured as much salt I could into the water until the water couldn't dissolve anymore. So it was fully, it's saturated to its capacity. So just poured a lot of salt in there. I already put the gummy bears in each in the respective cup, and it's only been maybe a little over an hour, hour and a half to 2 hours. I lost track of time, but I took them out, and I'm not sure if you guys can see, but already there's already a noticeable difference in size um, between the one that was put in the distilled water, which is this this one right here, and then the one that was put in the saturated salt water. Uh, yeah, as you can see, I'm trying to get the right angle, but there's clearly already a size difference between the two. And just from without even touching it, uh, this the one with distilled water is visibly more swelled up, seems more bulbous, whereas the red one that was put in the salt water, it seems a little shriveled up and more compact to itself, starting to lose some of its original shape. And the distilled water gummy bear is significantly more um, augmented in its feature and its size. Now, more than just even the side of the observation of the size, even just upon really just like touching them, the texture feels very different. The one with the distilled water feels very watery. It feels like it's been pumped up with water, and just a very wet texture. Whereas the one with the salt water, there's more of a grip to it, and um, doesn't feel as wet as the one with the distilled water. And just one quick more thing. I also noticed that my fingers aren't as sticky as when I touch the one with the distilled water, and that is also making the implication that once again the distilled water gummy bear is filled up with water, and obviously, as I mentioned before, the one with the salt water is starting to lose some of its structure. It's becoming more shriveled up, exposing some of that sugar in the gelatin, and even that I'm able to feel through just the how sticky my fingers are. Um, but after touching each of these gummy bears. Okay, so let's break this down. What's going on here? What's happening? This experiment, as you can see, using different solutions with a different solute and content between the two. One is obviously just distilled water, 100% purified water. Other is more saturated with salt, more solutes. The juxtaposition of these two solutions and the interaction and the effect that it has on the gummy bear really demonstrates the osmotic diffusion, osmotic pressure, and like the any really other diffusion, the gradient, the flow of the gradient is from high to low, and that's precisely our definition for osmosis here, which is the flow of water from higher concentration of water to lower concentration of water, and that's clearly visible here, as you can tell. When we put this for the distilled cup, the distilled water cup, when we put the gummy bear in um, the the solution, Obviously, there's more water from the the solution than it was in the gummy bear, so the water would flow from high to low. Whereas the opposite was true. There was more water content in, or there was more water in the gummy bear per se, relative to that of the salt water, since it was all saturated with salt. Now water will travel from high to low, and the a way I like to think about it is that something my biology teacher told me in high school is that water just wants to travel wherever it can dissolve something, or interact with solute. So if there's more, wherever the solutes are and wherever less of the water is, that's where water is going to flow from high to low, and that's clearly visible with, as you can see, the observations with these gummy bears. Continue just to expand on the discussion we have in osmosis. There are two types of solutions which are represented by the distilled water and the salt water. There we have our um, hypotonic solution and our hypertonic solution, and based on judging just the name hypo, under, or hyper, higher, the solution is hypotonic to the cell if the solute concentration outside the cell is lower compared to inside the cell. And hypertonic solution, the opposite of that is true. If the concentration of the solutes is higher compared to inside of the cell. So the hypertonic solution here, in relative to the solute concentration, it would be the salt water, because there's more salt. There's a higher concentration of solutes than compared to inside of the cell. And whereas the opposite is true for distilled water solution, there's obviously the solute concentration is lower than inside the cell, with more water. But in summary of this experiment, each ingredient or each component of this experiment represents something. So um, as we were presented with the prompt, the discussion talked about sugar, gelatin, and the gummy bear. Well, the sugar in the gummy bear, it acts as our solvent, and the gelatin, it holds the semi-solid solution inside the gummy bear, and finally the gummy bear is that acts as the semi-permeable membrane of the solution inside. So the gummy bear is basically a simulation of the cell, and because it's semi-permeable, then we are able to see the interaction of osmosis from in the net movement of water from high to low, and compare those the how osmosis really works with hypertonic solution, more solute concentration compared to the inside of the cell, or the gummy bear, versus hypotonic solution, less solute compared to inside of the gummy bear once again. So each component represents something, and this experiment really just goes to demonstrate the effect of osmosis, osmotic pressure, using a tasty snack and just some water and some salt that you can find in the kitchen. And as far as this experiment goes from a scientific standpoint, in terms of experimental design, ways that can improve this experiment is to really, since we're measuring the size difference of how the solution impacts the movement of water, to really isolate these components, we can set a standard. We make sure that we're pouring equal as much as water. We're pouring, or we're refrigerating, not refrigerating, but we're letting them sit still rather, in each solution for the same amount of time. Just trying to keep everything as a constant, isolate any other variables that aren't relevant to this experiment, and to really measure our dependent variable, which is we can extract our maybe the weight of the gummy bear as something that we can measure to be the factor of size. So we can use a scale. We can implement a scale um, to see the difference of weight. That's comparing the weight of the distilled water gummy bear, seeing if it weighs more than the regular gummy bear, and comparing that to to also the saltwater gummy bear, see if that weighs any less, and obviously, and to increase and really just um, show this experiment as credible. This experiment has to have additional trials, multiple trials that really controls these other variables and to maximize an accuracy and production of scientific result. But yeah, that was this experiment for the gummy bear experiment, and um, from this we're able to see how water moves in different types of solutions with solid concentration.